Uh, Hello everyone, my name is Kitty Tripathi and I am faculty in Electrical Engineering Department BBD and IIT Lucknow, and today we will be discussing unit number 2, time response analysis of the subject control systems, bearing unit code subject code as KEE 502. So let us begin. But before we start in discussion of this unit, let us understand what is the course outcome of this unit, meaning that after completion of this unit, what are the things which we will be able to understand when we have completely understood this unit. So let us see that. So we say that after completion of this unit number 2 of control systems, we will be able to measure all the performances of every basic control systems which we have studied till now. Later in this unit, we will also be discussing how to evaluate the parameters which is defined for the studying the performance of any control system, and that too in time domain. So at this end of this unit, we will also be able to do this. Not only this, we will also be able to understand basic types of controllers which are being used in this control system. Okay. As well as after we have studied this unit, we will also be able to comment and understand about how are the design specifications declared or understood in various types of controllers which are used in general control systems. So basically we will be dealing with time response here. That means the output of the control systems when measured in or represented in time, how are the response going to be, what are the various parameters which will define the performance, as well as what are the various types of controllers we will be dealing with. Yeah, but before beginning or jumping into the concept of time domain, there are few prerequisites which is required. So, to understand this unit, we should have a thorough knowledge of Laplace transforms. We should also have knowledge of time domain analysis. When we are studying, we also require the basics of open and closed loop systems as well as the study of transfer functions. So let us begin with the unit. When we say time response, what is the meaning of the term time response? ठीक है, अगर हम टाइम रिस्पॉन्स की बात करते हैं किसी कंट्रोल सिस्टम में, तो उसका मतलब क्या है? उसका मतलब है कि आउटपुट ऑफ द कंट्रोल सिस्टम इज वेरिंग and we have to define that variation in time. And why will output vary? When the input will vary. And when why will input vary? If input is a function of time and it starts varying, what will happen is the output of the control system will vary, and when this output will vary with respect to time, we say that this time response is declared or is defined in the system. As we can see in this graph that the if we represent any output of any system with respect to time and we try to plot a graph, we can just see two parts in this graph. See here, we can make a boundary and we can divide this graph into two parts. One part is called as transient state and other part is called as steady state. Now what is transient state? We say that whenever this time response or this response which is varying with respect to time is dying out after a certain period of time, that see this part of the graph is going to end, and then what is happening here, we can see that it has reached to a particular value, maybe it is 1 or any value. If it has reached to a particular value, we can say that what has happened, a steady state has been achieved, or whatever the final value we are having a desire. Like अगर हमें आउटपुट में 1 एम्पलीट्यूड चाहिए, वेदर इट बी ऑफ एनी यूनिट्स और एनी वैल्यू, राइट, तो अगर हमारा आउटपुट हमें कंट्रोल करके 1 डिफाइन करना है, तो इट इज़ नॉट लाइक दैट कि वेन एवर वी गिव अ सिग्नल, इनपुट सिग्नल एंड सडनली आउटपुट रीचेज टू 1, इट नेवर हैपन्स. व्हाट हैपन्स एग्जैक्टली इज it gradually changes and then reaches to a value which is called as 1. So what is that gradual change? That gradual change in output with respect to time is defined as transient state, right? And whenever this transient state gets over, the final value is attained, and that final value of the output which was desired by us is called as steady state response. So whenever we talk about time response, हमें एक चीज़ क्लियर है कि अगर हम टाइम रिस्पॉन्स को डिफाइन कर रहे हैं तो हम लोग फाइनली टाइम रिस्पॉन्स को 2 पार्ट्स में डिफाइन करेंगे. 2 पार्ट्स में डिफाइन करने का मतलब वी कैन टेल दैट आउटपुट ऑफ एनी कंट्रोल सिस्टम if represented in time can be categorized into 2 sections. One segment is called as time transient response of the output, and the other segment is called as steady state response of the output, right. So, mathematically when we define, we can segregate it into 2 parts. One is called as time response of transient behavior and time response of steady state behavior of a system, right. Let us move further. Let's dig into this term time response and steady state response. क्या है ये term time response and steady state response और क्या mathematical significance है इन terms का. So let us understand that also. So what happens is when we are applying any input to the control system, what will happen? If an input is applied to any system, what will happen? Output will be produced, and what do we desire in a control system? हम लोग बेसिकली जो कंट्रोल सिस्टम्स टर्म यूज़ कर रहे हैं, क्यों कर रहे हैं? क्योंकि हमें जो आउटपुट रिसीव होना है, हम चाहते हैं कि वो हमारे डिज़ायर्ड वैल्यू से हो. दैट इज देन ओनली वी विल से इट इज़ कंट्रोल्ड, राइट. सो व्हेन अ सिस्टम इज टू बी कंट्रोल्ड, what we will do, we'll send some signal or give some input, or we can call as a reference value. We'll set a value to the system, we'll give that value, and we will assume that with giving these values we will be getting certain value. मतलब मान लेते हैं अगर हम 10 वोल्ट सप्लाई दे रहे हैं and if we are getting 1 ampere, तो and the system is linear and it is linearly varying with time with unit 1 suppose. So if I am giving 20, it should vary to from 1 to 2. So in such cases, when we are changing the input, what are we having? We are predicting that there is a certain, and that prediction is based on mathematical equations of the system, and that is defined by transfer function. ठीक है, तो जैसे ही हम कंट्रोल सिस्टम में हमने यूनिट 1 में ये चीज़ देखी थी कि हम लोग ट्रांसफर फंक्शंस का यूटिलाइजेशन कर रहे हैं किसी भी सिस्टम को डिफाइन करने के लिए, राइट. नाउ इज़ द टाइम टू अंडरस्टैंड कि क्यों ट्रांसफर फंक्शन हमने सेलेक्ट किया था. बिकॉज transfer function, when we talk about transfer function, what do we say? Transfer function is the ratio of Laplace of output upon Laplace of input at 0 initial conditions. So when initial conditions are 0, this is called as transfer function times output upon input in Laplacian domain. अब what are we saying? We are saying कि इस RS को अगर हम वेरी कराएं टाइम के साथ, तो what can happen? See, this is giving some value. Let us assume that it is giving a value t of f. ठीक है. If it is giving a value t of f, t of s, I am sorry, it is s here. If it is giving a value t of s, this is a transfer function. It is having any particular expression in Laplacian domain. अब अगर इससे कहें हम कि हमें output c चाहिए, so what we will do? The basic mathematics says that we will multiply this transfer function with this input signal, ठीक है, and what we will get in result is the output of the transfer function. Now this output is in Laplacian domain. What if we want the behavior or the output in real times or in real conditions? What we will do is simply take inverse Laplace transform, ठीक है. जैसे ही हम लोग इन्वर्स लाप्लास ट्रांसफॉर्म लेंगे, हमें क्या मिल जाएगा? What is inverse Laplace transform? It is used for converting any value from frequency domain back into time domain. So what we will get is, we will get the value of Ct, and what can we see it here? That this output which is represented in time domain is dependent upon what? Input value r of s, or when it is converted r of t, right? इसका मतलब क्या है? इसका मतलब ये है कि ये इनपुट जब किसी सिस्टम में अप्लाई हो रहा है, एंड व्हेन इट इज वेरिंग विद रिस्पेक्ट टू टाइम, वी शुड हैव अ वेरिएशन इन आउटपुट एज वेल, बिकॉज इट इज डायरेक्टली डिपेंडेंट ऑन दैट, राइट. सो व्हाट हैपेंस इज, let us assume that if we are giving a particular value to as input to a system and we get a certain value as output. Does it happen that immediately in a physical system when we connect a value to an input to a system, we get exactly the value at the very instant when we have connected? No, it never happens. Take an example of a fan. If you switch the regulator to 5, if the fan is already in the on condition, then also it will take certain amount of time to increase its speed and reach to the value where that regulator has been set to 5, right? इसका मतलब क्या है कि there is a part of the system, a part of the output which varies and then it dies out, and when that part dies out, what remains is the actual desired value which we are desiring from an system. That means the controlled value जो हमें चाहिए वो एक पर्टिकुलर शॉर्ट टाइम पीरियड के बाद हमें मिल रही है, और एक शॉर्ट टाइम पीरियड तक हो क्या रहा है, देयर हैज़ बीन change in output, right? So that change in output for short time period is called as transient response, and when this transient response have been died out, the value what we have attained is called as steady state response. अब mathematical representation का बात करें, so this I have already told you that this time output response can be divided into two parts. One is called as transient response, another is called as steady state response. Let us write SS. ठीक है, other is called steady state response. Now what will happen if we are asked to calculate time response separately from a system? We can be asked na. So what does logic say? Logic say that after a certain period of time, this time response, this transient response is going to die out, and then only steady state value will be achieved, right? So what is happening? Time is dying out after a certain period of time. Let us suppose we have expression of time output response in terms of time, ठीक है? If we want to extract what is the transient response from that system, what we are going to do is, what we will basically do in that system is, we can limit the time tending to infinite, and we know that after a certain period of time the transient dies out. That means this at time equal to infinity or tending to infinity, the transient response is going to die out, and when transient response is going to die out, what remains is the only steady state condition. So basically from this mathematical expression we can segregate or separate from a given function what is the value of transient response and what is the value of steady state response. How? Let us check that. See, we are aware that we need transfer functions to determine the output of the system, and that is completely dependent upon input, right? Because as the input value changes, the output is also going to change. Input, when it is a function of time, it is giving an output which is also a function of time. Now why are we so much interested in calculating all these things? If we are getting a controlled output, well and good, na? We are happy with response what we are getting. Why are we so bothered that we should calculate time separately, we should calculate steady state response separately, why do we bother? What is the need of doing it, if we say that? So first of all, why are we going to calculate? Before beginning the calculation, let us understand why are we behind it, why are we going to calculate time domain response, why it is so much of importance to us. So the thing is that this input which we are providing to the control system is a dynamic value, right? Or it is a function of time, we can say that. It is an expression of time because we are varying this value and we are getting certain output. अगर हम किसी सिस्टम को कहते हैं कि ये कंट्रोल सिस्टम है, कंट्रोल्ड सिस्टम है, सो व्हाट डज दिस मीन कि हमने एक पर्टिकुलर वैल्यू दी, उससे एक पर्टिकुलर वैल्यू आउटपुट में मिली. हम अगर उस वैल्यू को कुछ और चेंज कर दें तो वी आर अवेयर कि हमें आउटपुट क्या मिलना चाहिए, वही वैल्यू मिलनी चाहिए, right? This is what is the concept behind open loop and closed loop. We have already dealt that in unit number 1. So basically we are aware कि कोई भी system में if we are changing input, we are getting output as per our requirement, ठीक है? So what is happening? We are changing the input. That means when the input is getting changed, output is getting changed. What if this input is a function of time? Is what my concern is, because in general it happens that we are having analogous signals everywhere. Real time physical systems are generally giving us analogous input. What about that in the actual scenario? Even if it is not, analogous and digital, but it is having a pulse of train, right? So basic concern is, if the input is varying with respect to time, what will happen to the output? Since output is directly proportional to this input, we have seen that CT was proportional to RT, right? So when this CT is going to change, RT is going to change, CT is also going to change. That means time response of the output is also going to change. When this time response of output is going to be changed, this behavior of the system or the output, what does it become? It become dynamic for us, and hence it is important for us to analyze the behavior of the system. ठीक है? And when we are calculating the behavior of the system, we should think two things in mind, keep two things in mind rather, right? What are those? We have seen that this CS, Laplace of output, was equal to transfer function into Laplace of input, or what we call as reference input for our system. This is the expression. So हमें क्या देखने को मिल रहा है? If we take inverse Laplace and get the time response, what is the factor on which it is depending upon? It is depending upon this Ts and this Rs. That means we are very much dependent upon the nature of the input. If this input nature changes, we are going to get change in the output as well. And the second thing is the system itself. That means the mathematical modeling of the system, if that changes, that configuration is changing, this Ts is changing, and this Ts is changing, then output is changing. So when we are analyzing this output, and especially in time domain, we have to consider these two things as important factor for us to begin the analysis, which is the nature of the input as well as mathematical modeling of the system, which we are taking into the consideration, right? Now, before we dig on to what can we do about calculations in time domain, let us focus on one more thing, which is that what about the information of this input signal in real world, in actual systems? It is not necessarily, compulsion for any of us that we have a full idea of what is this input system going to be ahead of time, that how much output we are going to get after a certain period of time, we are not aware. It is in real world में अगर आपसे कोई example दिया जाए और आपको बोला जाए कि control this electric circuit, right, and we want certain outputs at certain conditions of time, we are not aware that if we have been only given circuit, we are not aware that this input signal, how much value it is going to give into the future. That means in physical systems, in actual appliances or home appliances which we are using, we are not aware completely that how is exactly this input signal, wherein we are not doing any kind of calculation in our homes, right? But even if we want to analyze and begin the analysis in time domain, if we have certain kind of informations, we can begin with it. And in that certain kind of information, what are those certain kind of informations, by the way? They are the mathematical modeling of the system as well as the input. What if we are not having the complete information of how input is behaving in entire time domain, how it is plotted in entire expression? So we may not have full information of the input values. What do? It is difficult, otherwise it will be very difficult for us to understand and to solve it. So in generally we say that for an actual input signal, this calculation becomes more tedious, more difficult. And what do we require to simplify the calculation? Then only we will be interested in doing time domain. If it is a very complex process and we are unable to determine anything from it, why will we choose time domain? हम time domain analysis क्यों choose कर रहे हैं? क्योंकि हमें अपनी जो भी controlled value चाहिए वो एक proper हमें informations के साथ मिले कि हमें किस particular time पर कितना value मिल रहा है, कौन सा parameter change कर दें तो क्या हो जाएगा, So these kind of things, if we are able to calculate easily, it is of importance to us. If we are itself confused in how to calculate those values, it will be complete waste of time as well as energy doing time domain analysis. So for simplifications, what do we do? Rather than taking these actual input as the input of the system, what do? We take certain test signals, and that test signals can be used, or we call as standard signals, standard input signals. For that we, because हमें क्या है, mathematical architecture पता है, we have mathematical modeling of the system, हमें output निकालना है, तो what can we do? We are not aware of actual systems, but we want to control what is in our hand. Our hands we have test signals. So we can generate output for those test signals, and similarly if we are getting the exact behavior of the output, how it is behaving in entire time domain, what can we do is we can design a controller and probably do whatever we want to do it from it, right. Now let us see for an instant this expression, C of t is equal to 10 plus 5 e to the power minus t. We are saying that what first of all, this is an expression of a time response of any kind of a system, we are not aware what it is. Since we have been certainly assured that in time domain analysis we are having values with input as well as with transient as well as steady state also, because that are the two components. What we have been told, there are two components, which is time response and steady state response, and see what we are having, we are having a certain kind of expression. Now if it is our requirement, so how to determine the, let us suppose, transient response, and why we are so much interested in transient response, because that is the response which is preventing us to reach the steady state value, the desired value very fast quickly, which we want. We definitely want, the minute we supply the input, we get the output in the least time variation. If we got to have the values with least time variation, हमें क्या चाहिए होगा कि हमारा ये वैल्यू जितना कम से कम हो उतना बेहतर है. क्यों? क्योंकि the faster the system dies with the transient, the quicker it get to reach the steady state value. The faster it reaches the steady state value, the better the system we have. ठीक है. So अगर इस एक्सप्रेशन सी टी के साथ अगर हमसे ये पूछा जाए कि आइडेंटिफाई करो कौन सा कंपोनेंट है यहाँ पर, क्या इस एक्सप्रेशन को देखकर हम ये आइडेंटिफाई कर सकते हैं कि ये टर्म ट्रांजिएंट टर्म है सिस्टम का? सो येस वी कैन. हाउ? व्हाट डू वी डू नीड टू डू फॉर ट्रांजिएंट? व्हाट वी से दैट इट डाइज आउट आफ्टर सर्टेन पीरियड ऑफ टाइम. सो वी डोंट नो दैट व्हाट इज द सर्टेन पीरियड ऑफ टाइम, but we are sure that at time tending to infinity it is going to die out, right. So let's see, at time tending to infinity, what is the, which part is going to die out? E to the power minus, sorry, it is let me rewrite it. We are aware that it is divided into two parts, time transient response and steady state response. When we have to calculate transient response, what is the requirement we are having? That this output it dies out when time is tending to infinity. So for obtaining the transient response from a particular system, which is this here, what is our requirement? Our requirement is to somehow limit the time tend to infinity, and what will happen? One of the component is going to die out. The component which is going to die out will be the transient component. Here it is very easy to understand because we have taken a very simple example which is quite distinct. So what do? If we take limit t tending to infinity for the output, what it is? 10 plus 5 e to the power minus t. Now it is very clear to us what is the thing which is varying with time. See here, this, and when this t tends to infinity, which of the part is going to die out? See here, it is e to the power minus infinity, this is the part which is going to die out. So we can say this part is the component of the output which is transient response. right? And what remains is steady state response. Correct? But the main issue is we are not aware ki in every situation the output is not going to be so simple, and we are not aware about the input signals. So, what do we basically do? We quickly jump onto the standard signals. Now, let us remember what are the standard signals which we have already dealt in the previous subjects. Those standard signals are impulse, step, ramp and parabolic. What is an impulse signal? We are aware that an impulse signal is represented at only t equal to 0, and at all the other values it is infinite, it is 0. It is only existing at t equal to 0, as we can see here in this figure and in this expression as well, right? और अगर ये magnitude जो है इसका value हम 1 substitute कर दें, then what do we say? This signal is called as unit impulse signal. We have already studied a lot about these signals in BSS. So, we can quickly recapitulate. What about step signal? We say at positive time it is giving a constant value A, and at negative and at time less than 0 it gives value equal to 0 in time domain. That means it is having a value representing a particular step, and when this magnitude is equal to 1 we say this is a unit step function, right? Similarly, ramp signal, what do we say? It is varying with respect to time and it is varying linearly with respect to time. What about the slope of the line then? It is equal to this value A, ठीक है? What happens, how can we determine this value A? We know how much it is moving in x direction, we know how much it is moving in y direction. Can't we calculate the slope of this line, this divided by this, right? So, we are aware if this slope is equal to 1 we say this signal is a ramp signal. Slope is 1, it is a unit ramp signal. And finally, parabolic signal. What about the parabolic signal? Parabolic signals में क्या बोल रहे हैं? It is a function of square of time, and it can be standardly represented as at square by 2. You have already studied this. What is this going to look like? Something like this. It is having a slope. This A is slope, as we all are aware of it, and y is equal to t square by 2 type का ही format होता है parabolic expressions. We have studied in mathematics. What is this A here? It is the slope. And what if this A value is equal to 1? It becomes a unit parabolic signal. For understanding the step signals and various types of standard signals, rest of the content we will be dealing in upcoming lecture. Thank you.